This video is about the special fractions of a circle that we'll be needing for all of our trigonometry this semester. And to understand these special fractions, we're going to look at a clock, an analog clock, which is hopefully a familiar image. And if I start over here where the 3 o'clock hour is on the right side, and start rotating counterclockwise back up to the 2, I'm going to put a dot at each of these hour spots where I'll stop, and then back up to the 1, and then back up to the 12 at the top. Then we'll continue back over to the 11, the 10, and the 9. I'm going to pause there for a moment. We've now rotated around half the clock, but interestingly, we're going to call that length of rotation 1. Okay, so half the clock, like we just rotated, is a length 1. So then if I were to continue rotating from the 9 down to the 8, and the 7, the 6 at the bottom, over to the 5, the 4, and then back up to the 3 where we began. Since we started there, we could call that 0. But since we ended there, and the entire length around the circle will be 2, we could also call that 2. So then, if you consider the fractions made of this circle by each of the hour locations, starting here at 0 or 3 o'clock, the first rotation up to 2 would count as 1/6 of our entire circumference. Remember, half of the circumference was 1, so 1 hour out of that would be 1/6. If I were to continue counting by sixth, then, up at the 1 o'clock spot, I would have 2/6 of a rotation, which of course, if we reduce, would be 1/3. I could rotate still more to the 12 o'clock, where it would be 3/6. Of course, reducing that gives us 1/2. And I'll keep this counting by sixth going all the way around. So I'd have 4/6 over here, which of course is 2/3. Then I'd have 5/6, 6/6. Of course, we've already called that 1, but that's making sense. I'll continue to get 7/6 over here at 8 o'clock, and then 8/6, which of course reduces to 4/3. And then 9/6 down at 6 o'clock here, which will reduce to 3/2. And then 10/6, which, yes, is 5/3 reduced. And then 11/6 at the 4 o'clock hour here. And then back up to 12/6, which of course is 2. That's where we started at 0 or 2. All right, so what you're seeing now is the first set of important or special fractions of our circle. They're starting at the 3 o'clock hour on the right side, which we'll call 0, and counting by sixths for every hour going all the way around the circle. There's one more set of fractions we're going to lay on top of this. And for these marks, again, we'll start here at the 3 o'clock spot where we'll call 0. If I were to rotate up to the halfway between 1 and 2 spot, I'll add a dot there. That's going to turn out to be one of our special places. If I continue that length of a rotation, I would also stop up at the 12, again, where we've already made, and then over between halfway between the 10 and the 11, down where the 9 is, halfway between the 8 and the 7, down where the 6 is, and then halfway between where the 5 and the 4 are. So those extra markings we're going to also put down here, but those will be counting not by sixths, but by fourths. So if I start over here, where we started before at the 3, and rotate up to this first extra mark I put, that's going to be a marking of 1/4. If I rotate up to the second one here at the top, that's 2/4, but of course that reduces to 1/2, which we already have. If I continue by fourth, this other marking between the 10 and the 11 will be 3/4. Continuing down to the 9-hour location on the left side here, this would end up being 4/4, but of course that's already written reduced as 1, so we'll just rewrite or use that again. If I continue down to the next marking here between the 7 and the 8, this fourth marking will be 5/4. And then down to the bottom, I'll have 6/4, which reduces to 3/2 again. And then all the way over here between the 5 and the 6, this extra marking will make 7/4. And then if I continue back up to the 3 o'clock spot, I'd have 8/4, which again is 2, but that's already where we've been, so we'll leave it at that. So what you see now is the full clock of special fractions. I'm going to go through and circle the reduced versions because those are the ones we'll be using. So we have 1/6, 1/4, 1/3, 1/2 at the top, 2/3, 3/4, 5/6, 1, 7/6, 5/4, 4/3, 3/2, 5/3, 7/4, 11/6, and 2. Those are all of our special fractions around a clock. All right, now we're going to translate everything we just did on the clock to a plane circle that's positioned on the x and y axes of the Cartesian coordinate plane. So I'm going to mark some points of intersection here where the circle and the x-axis intersect on the positive side. We'll call that point 1, 0. Where the circle and the y-axis intersect on the positive side, we'll call that point 0, 1. Over here on the left, where the circle intersects the negative x-axis, we'll call that point -1, 0. And down at the bottom, where the circle intersects the negative y-axis, we'll call that point 0, -1. So as you can tell by these coordinates, this implies that our radius for this circle is 1. That's known as the unit circle. And we'll be using that a whole bunch. The unit circle is this, where radius is 1. Now, as you might recall, the circumference of any circle has a formula known as 2 times pi times radius, or 2 pi r. And if our radius is 1, then the circumference of this unit circle would be, well, 2 pi. Okay, what that means then is that if I start over here at this point 1, 0 and start rotating counterclockwise along this circle, of course, eventually I'll hit up here at the point 0, 1. I'll keep going on down here to the point -1, 0. That would be half a circle, but if the full circumference is 2 pi, then half of that, of course, would be 1 pi. Okay, if I keep rotating, I'll eventually hit this point 0, -1 at the bottom, and then continue counterclockwise all the way back to where we started here at the point 1, 0. So that full circumference, as we've already mentioned, is 2 pi, but you could also call it 0 since we started there, so I'll say 0 or 2 pi. Now, all we're going to do is slice this circumference of a circle up using the fractions we put on the clock earlier. If I slice up here at the point 0, 1, that's halfway from 0 to pi, or in other words, that would be called pi over 2. And then, of course, this is 1 pi. If I keep counting by half pi's, when I end up down here at the point 0, -1, this would be 1.5 pi, or in other words, 3 pi over 2, or 3/2 pi. And then I'll continue back up to get 2 pi, which is, of course, where we start and end. All right, so those are the half pi countings. Let's add some of the other common fractions that we've already discussed on the clock. One of those was all the 6th marks. If I put some markings in for those, there should be 2 of them in each quadrant, cutting each quadrant into 3 equal arc pieces. And if I put those fractions in that we've already seen on the clock, those would end up as, and now they're all in terms of pi since we're talking about the circumference. The first fraction you might recall is 1/6, so we'll call that pi over 6. Next was 2/6, which we'll reduce to call pi over 3, or 1/3 pi. Then it would be 3/6, or 1/2, I already have it there. Then 4/6, or 2/3, or 2 pi over 3. Then 5/6, or 5 pi over 6. And then 6/6, which of course is 1. And then 7 pi over 6. 8 pi over 6 will reduce to be 4 pi over 3. 9/6, or 3/2, we already have there. 10/6 will reduce to be 5 pi over 3. And then 11/6, or 11 pi over 6. And then back to 12/6, or 2 pi. So as you can see now, we have our full unit circle with all of our 1/6 and 1/2, which happen to overlap at places, markings on it. Now you might recall there's one other set of fractions we're also going to put on this circle, and that would be all the quarter markings, which happen to be right in the middle of each quadrant arc. So I'm going to add some marks for those, and then we'll go through and label them. This first one, as you might recall, was 1/4, or pi over 4. And then, of course, 2/4, which we've already borrowed as 1/2. And then this would be 3/4, or 3 pi over 4. 4/4 is the same as 1 pi. Then we'd have 5/4, or 5 pi over 4. 6 pi over 4 reduces to 3/2, which is already there. Next would be 7 pi over 4. And then 8 pi over 4, which is 2 pi. So there you have it. Those are all of our special fractions on the unit circle now. Unit circle, of course, being a circle of radius 1, which gives us a circumference of 2 pi. And then slicing all the special fractions gives us all of these arc pieces or lengths that all start from the point 0, the point 1, 0, and then extend to various lengths depending on how much of the circumference they are, or what fraction of the circumference. And all the special ones are now marked on this circle.